Lesson 65 has two parts, and the first part is on addition of radical expressions, and then the second part is a totally different concept on weighted average. So in part A, let's just do some practice problems to understand how to add radical expressions. Radical expressions, those just have a radical sign in them, or a square root sign. And so like in practice problem A, let's add 4 times the square root of 5 plus 6 times the square root of 5 plus 3 times the square root of 5 together. The best way to understand how to add radical expressions is to just think how I have written there in red. Think of similar square roots as similar variables. If you think of those similar square root signs or radical signs as similar variables, then that will help you understand this. For example, in practice problem A, all of the square roots are the same, right? They're all the square root of 5. So a way of thinking of this problem, this isn't the right way to solve the problem, but just think of it like 4x plus 6x plus 3x. If you think of it that way, you already know how to do a problem like that. That's just adding like terms together, and you would end up with 13x. So think of the square roots as similar variables. The square roots that are similar, think of them as similar variables. So this answer would just be 13 times the square root of 5. That would be the addition result of that problem. Let's do another one. Let's add these terms together. Square root of 3 plus 2 times the square root of 7 minus 4 times the square root of 3. Okay, just keep that thought process in mind. Think of similar square roots as similar variables. So we have a square root of 3 and we have a negative 4 times the square root of 3. We have two terms there that both have a square root of 3 in them. And we could think of those as x minus 4x. And so that would be a negative 3x, right? Or a negative 3 times the square root of 3. But then we have the 2 times the square root of 7, which is not the same. So we just leave it alone. And there's our simplification. 2 times the square root of 7 minus 3 times the square root of 3. That's as much as we can add for that problem. Now, of course, we could work this out on a calculator, but that's not what they're wanting you to do here. They don't want you to do 2 times the square root of 7 on your calculator minus 3 times the square root of 3 and get a number with a bunch of decimal places. They just want the number in terms of square roots and whole number factors. Let's do one more problem. Add these together. And first thing you do when you see a problem like this where you're adding radical expressions is to think of similar square roots as similar variables. So we have a couple of expressions there with the square root of 2 in them. Those are similar square roots, so we think of those as similar variables. So in the same way that 4x minus 6x would equal negative 2x, 4 times the square root of 2 minus 6 times the square root of 2 would equal negative 2 times the square root of 2. And then that square root of 3 on the end, it's not similar, it's not a like term, and so we would say minus 3 times the square root of 3. We would just add that back on the end. That's as much as we can add for that problem, and so that would be our answer. So the key concept to remember when you're adding radical expressions is to think of similar square roots or similar radical expressions as similar variables. Then it just becomes an adding like terms problem. Part B is about weighted averages. When you're dealing with weighted averages, it basically means that each amount is counted a certain number of times, and you have to look at the total weight of all the items in order to figure out the average correctly. Let's just do a practice problem. Look at practice problem D. The scores on the tests were 76, 87, and 100. What was the weighted average of the test scores if the tests were weighed 1, 2, and 4 respectively? So respectively, that means that the first test I put up there, 76, had a weight of 1, 87 had a weight of 2, 100 had a weight of 4. So the weight, that means that 76 was just counted one time, 87 was counted twice, and 100 was counted 4 times towards the total score. So what you do on these, you don't just say 76 plus 87 plus 100, and then divide all that by 3. You have to concern the weight in this issue, the weight of all the tests. And so let's not put that 3 there. The 76 was just weighted one time, so we would multiply it by 1. The 87 was weighed twice. It counts twice as much, basically, as the first test. And so we'll put a 2 there, multiply it by a 2. The 100 counted 4 times more than the first test, and so it has a weight of 4, and we just say 4 there. And so therefore, our total number of tests is 4, 5, 6, 7. 1 plus 2 plus 4. So that's what we divide by. So if we do the math there, 1 times 76 plus 2 times 87 is 174, and then plus 400, that would give us 650 over 7. And so we just divide that, 650 divided by 7, to figure out what the weighted average is, and that would be 92. We can just round it to 1 decimal place, 92.9. So that's the weighted average of those test scores. So when you're doing weighted average problems, the weights, that tells you how many times each value counts, and then you end up with a total count, and that's what you divide by to get your average. Okay, well that's all for lesson 65.